one-to-one function and their inverse. A function have an inverse if the function is one-to-one. A one-to-one function meant for each output, there's only one input. So for example, in this case, the output 4 have two different input, 3 and 2. Therefore, the function g is not one-to-one. Another way of looking at a one-to-one function, if you are given a graph, is to use the horizontal line. If the horizontal line intersects the graph at more than one point, then the graph is not of a one-to-one function. Okay, so for example, in part A, if I draw a horizontal line, I intersect the graph at 2 points. So f of x is not a one-to-one function. Okay. So how do we use the definition to test whether a function is of one-to-one or not? So a function with domain A is called one-to-one function if no two elements of A have the same image, that is, f of x1 is not the same as f of x2 whenever f of x1 is different with f of x2. Okay. In other words, no two x value in the domain have the same y value in the range. So how do we check whether g of x equals x to the fifth plus 8 is a one-to-one function? So first, let x1 and x2 be in the domain of g of x, and x1 is not the same as x2. Then g of x1 is equal to x1 to the fifth plus 8. G of x2 equal x2 to the fifth plus 8. So g of x1 equal to g of x2. If and only if x1 is equal to x2 in this case. This means g of x1 is not the same as g of x2. So therefore, g of x is a one-to-one function. Okay. Talk about the inverse. If the function is a one-to-one function, then it has the inverse. So how do we find the... So if f is the one-to-one function with the domain A and the rank B, then the inverse function f inverse have the domain B and the rank is defined by f inverse of y equal x for any y that is in B. So we say that the domain and rank here switch. So find the value of an inverse function. Assume that f is one-to-one. Okay, if f of 1 equal 5, f of 3 equal to 7, and f of 8 equal negative 10, what is f inverse of 5? Well, f inverse of 5 is equal 1. We switch domain and rank, so the value of x and y switch. F inverse of 7 is equal to 3, and f inverse of negative 10 is equal to 8. Note that f inverse is denoted with the exponent negative 1. This is not the same as 1 divided by f, so don't ever put that into the calculator and get confused. Okay. So if f of x equal to x squared minus 2x for x greater than 0, we want to find f inverse of 8. This means 8 equal to x squared minus 2x. X squared minus 2x minus 8 equal to 0. And since x here is greater than equal to 0, f inverse of 8 is equal to 4. Inverse function property. Let f be a one-to-one function with the domain A and rank B. The inverse function f inverse satisfies the following cancellation property. F inverse of f inverse composed with f equal x, and f composed inverse f inverse of x is equal x for every x in B. Conversely, any function f inverse satisfy this equation is the inverse of f. To verify two functions are inverse of each other, we will do the composite. We have to do both composite. So f compose g of x is equal to 3 times x minus 4 divided by 3 plus 4. That equal to x minus 4 plus 4. That equal x. G compose f of x. That equal to 3x plus 4 minus 4 divided by 3. And this is 3x divided by 3 equal x. So this means f and g are inverse of each other. Let's take a look at the next one. So f compose g of x. And g compose f. So then f and g are inverse of each other. Let's see if we can find inverse function of a given function. To find the inverse function, we'll solve for x in the equation, and we interchange x and y, and we replace y by f inverse of x. Okay, so start with solve for x in the equation. We then interchange x and y, and this is our inverse. Okay, let's try for the next one. So then this is our inverse.